All right, so the first thing for this review that I gave you today was actually something that might come in handy, and that is our reference sheet. Now, this whole thing is not the reference sheet that you get on the exam. On the one side, you'll see it's labeled as Geometry EOC FSA Mathematics Reference Sheet, front side and then back side. Those are the formulas that you get on the exam. The other part that says not on the reference sheet, those are formulas that you need to know. So when you look at this reference sheet, there's a lot of things that really aren't even going to be that useful when it comes to the test, unfortunately. Like all this stuff in here, yeah, we have all these conversions. They give them to you. Are you going to have to use a lot of them? No. You might have to use them for like maybe 4 questions at most, I would say. But that's it. All right, they don't do a whole lot of conversions usually on the FSA. Now, the bottom part, this will come in handy. All right, you have sine, cosine, and tangent, the 3 trig ratios. So if you don't remember them, great, they gave them to you on there. Again, that'll come in handy during the calculated portion. Maybe not so much during the non-calculated portion. There might be 1 or 2 questions that you could use those for on the non-calculator, but they'll help you set up the ratios at least of sine, cosine, and tangent if you don't remember them. The next 3 there, you have the 3 equations for volume. All right, those are the 3 main equations that we talked about, which those come in handy. However, do they have names listed there at all? They say what they're for? No. This is how they're given to you on the exam. So you would have to know which one it goes for. So the first one says you have a big B and then the H. So that's base area times height. So base area times height, that works for 2 different things. Which ones does that work for? Oh, so base times height is square and rectangle. All right, and I've got that in all 3 of my classes, but this one's volume. So that's area. This one's volume. It's base area times height. So we're talking about 3-dimensional figures. All right. And you can broaden that just prism. All right. Any prism. This works for all prisms. Or it also works for our cylinders as well. Prism and cylinders use the same formula. They have 2 bases. All right. So it's the base area times the height. The next one, 1/3 base area times height. There are 2 shapes that I showed you. They could fit in a prism and a cylinder, but they came to a point. So they only had 1 base, and then it came to a vertex at the top. What were our 2 shapes that were 1/3 base area times height? Pyramid, all right. And no, again, it comes to a point. Cone. Yeah. So again, a prism and a cylinder use the same formula, base area times height. Then you have for the second volume formula, 1/3 base area times height. If they have 1 base and then they come to a point at the top of vertex, then that's our pyramid and our cone, right? They both come to a point, right? So that's 1/3 base area times height. Now, the last one, 4/3, pi r cubed. Well, it's cubed for a reason. We have radius, it goes in 3 dimensions. It makes a what? Starts with an S, sphere. All right. So those are equations that are given, although it doesn't tell us what they're for. So you have to know. Now, below those, they give you 2 formulas that we used way at the beginning of the year that deal with equations of lines, because we did talk about parallel and perpendicular lines on coordinate planes. So you may have to use those formulas down there at the bottom. And it's a good thing they give them to you because those are formulas that a lot of times people forget. Now, the rest of this formula sheet, everything on this other side, so all of this information over here, it's not given to you. All right. Again, those are things that we have done throughout the year. Some recent, some of them not so recent, that you have to know going in. If you don't know them, I highly recommend writing out some index cards and making flashcards of the formulas and then practicing them, because again, those will come in handy when you do the test. Some of the biggest things I'd say, of course, Pythagorean theorem. So and put a star there. Pythagorean theorem is something you're going to use multiple times all throughout the test. I'd also say all the translations, usually they like to test heavy on the translations, reflections, dilations. I left one out somewhere, but all of the transformation ideas that are over here, those are things that are usually tested kind of heavy. So I would make sure you know those things. All right. Let's go ahead and move on to the review itself. So we're going to start with number 1. I'm going to try and go as far as I can today. I'll probably get to around question 14, and then we'll pick up here tomorrow. But for question 1, given you have 2 lines and they intersect at point A. Now, they didn't give us any other information except for the names of these lines and that they intersect at point A. So here's point A. I'm going to throw some other points on here and say that this is X and Y. And I'm going to call this one, what was the other line? Z and W? Z and W. So if they don't have a picture, draw one. This is all I know. I have 2 lines intersecting. I actually don't know what they look like. Right? I don't know how they intersect. So the first question, the first option was, are they equal? Are they equal? Well, first off, I have no clue. And the drawing I just did, they definitely don't look equal, but they didn't tell me that they bisect each other. So I couldn't say for sure that they were equal. So no, that one's out. How about, do I know if angle XAZ is acute? No clue. In fact, in the one I drew, it was obtuse. So that's not going to be it. Are they perpendicular? Again, they didn't tell me how they intersect. They didn't tell me anything about the angles. So do I know anything like that? Now, number 4, you got to know some vocab in order to do number 4. What does this last word mean? Non-collinear. What does linear mean again? Linear means line. Collinear would be same line. Non-collinear would be not the same line. So X, Y, Z, and W, are they on the same line? Nope. That makes them non-collinear. So D is the correct answer. On number 2, they give us 3 lines intersecting at the same point. Now they are talking about whether or not these lines are perpendicular. Well, what 2 lines are we looking at? We're looking at R and P. So let me just highlight those in red here. Here's R, here's P. Oops. R and P, those 2 lines. Now, there are some angles all the way around here. 2 of them, here's 6, here's 3. Those 2 are the only angles that are between those 2 lines. In order for those to be perpendicular, what would 6 and 3 have to be? Okay, well, they're going to be equal to each other no matter what, because they're a pair of vertical angles. But what would make those 2 perpendicular if they were what? Well, supplementary means they add up to 90. That's 180. This one, again, in order for 2 lines to be perpendicular, how do they have to intersect? They have to intersect at 90 degree angles or right angles. So in order for those 2 lines to be perpendicular, 6 and 3 both have to be 90 degrees. Is that an option on there anywhere? So let's see. It says 2 has to be 90. No, that wouldn't be right. 6 has to be 90. That was one of the ones we were just talking about. So option 2 works. Now, they don't have 3 by itself on there anywhere. That would be 90. They're always going to be equal. But again, the question is, we need them. We want to know which one of this is enough information to say that they are perpendicular. So they will always be equal to each other. But that's not enough information to say they're perpendicular. So now, the other options include adding angles together. So if I look at angles 1 and 2 or 4 and 5 together, combined, those 2 would have to add up to 90. So the only other one that works here is the last option, 4 and 5. These two added together would be a 90-degree angle as well. So knowing that's 90 or knowing this is 90, those are two things that work. All right. Let's move on to number 3. All right, number 3 is dealing with translations. So it doesn't say anything about translation, but looking at what they gave us, we have the original values, and then we have A and B prime. And then also in our answer choices, they're adding and subtracting values from X and Y, which means that they're doing a translation. They're shifting all these points the exact same direction. Well, how do you do that? You need to figure out what the change is from the original value to the prime value. One way you can do that is through subtraction. So take the old value and subtract the new value to find how it changed. So on here, I'm going to take the -1 minus the -3. So -1 came from the X of A prime. -3 came from the X of A. And let's see, they changed by, well, if I change that to adding a positive, this is now +2. So the difference here is +2. Same thing for the other value. I took the old minus the new. Oh, sorry, I said that backwards, didn't I? Scratch that. I just did something backwards. That was bad. New minus old. New minus old. Or image minus pre-image. All right. New should always go first. All right. 2 minus -1. Again, adding. That's going to give me a difference of 3. And if you want to check this, did we do the same thing over here? Yep, we added 2. 2 plus 2 gives us 4. 1 plus 3 gives us 4. So what do? We did A. We added 2 and we added 3. Number 4. They give us some images. They want to know which one could be responsible. A reflection, rotation, translation, or dilation. Those are the 4 types of transformations that we talked about. Now, one of those 4, does it change in size? Did we change the size of our image? No, they stay the same. So which one can we cross out right away? Dilation is out because that changes the size. These are the same size. So that one's not it. All right. Next, one of those also keeps them facing the exact same direction and just shifts the image over. That's a translation. That's like what we were talking about in the last problem. So that one can't be this either. Now, reflection and rotation, they'll be the same size, they'll face different directions. So it could be one of these two. Which one is it? All right, so you say rotation. Let's see. If we were to take this image and rotate it, all right, would it face the same direction as this one? Now, that's hard for me to do on the board, but on a sheet of paper, you could do that. So on the actual test, if you wanted to look at a rotation, you'd have to sketch your image and then rotate it because you're doing a test on a computer. You already have this on your sheet right now. Try turning that paper and see if you can get that first image to look like the other image at all. You can? How? How much did you rotate it by? 90 degrees? If I rotated that 90 degrees, I would end up with H. Right here. And then it would have been like this. I think it looks something like that. Is that the same? Nope, it's not a rotation. It's a reflection. Let me first clear this off. What I just drew. Now, the thing that gets people on this one is most people think reflection and they think of 2 things, but there's three main reflections that we normally do. We do it in the y-axis, which would be flipping this over left to right. We flip it in the x-axis, which would be flipping it up and down. But then it's that third line that does this one. Reflect. If we reflect this in this line, it works. Every single one of these points equal distance to that line of reflection. So U and U prime, Z and Z prime, H and H prime, D and D prime. Whoa. What just happened? I don't know what just happened. Something happened with my computer. I can't see on my computer screen. That still shows it's recording. Helps if I can see what I'm writing on my screen. Can I still see up there? Well, let's change at least. If let me write, I just can't see what I'm writing. Interesting. All right, well. How am I going to do this? Hold on. Let me try minimizing the screen. And nope, I won't do that either. I got nothing but a white screen on here. All right.
Probably on share the screen.
Well, yeah, I'm sharing it. It's just not.
It's not have these different options if you want to go on the screen and on the computer.
Yeah, but it's not that. Like, look, it's just a plain white screen. I can't see anything, and it won't let me do anything else. I'll work with it. It's fine. All right, let's see. Number 5. Some of these questions you don't have to actually do the entire thing. So like number 5, yes, they give us two different cubes, and then they give us 2 figures, and they say they took P and it became Q. Well, if we just look at one of those cubes and not both of them, we can figure out this answer. Look at P. Let's see. I'm going to just draw random dots until I find where I'm at on the screen. Hey, there I am. All right. And I'm going to guess. Yes, somewhere there. Just remember, I can't see what I'm writing on my screen. But those rotated. Since those rotated, we can at least say how the top one changed. How did the top one change? Well, how did it rotate? Did it rotate clockwise or counterclockwise? Clockwise, yeah. So it went clockwise. And if we look at all the answer choices, let's see where I'm at. Yeah, oh, that's close there. There it is. 90 degrees clockwise. That's going to be our answer. That's the only one that goes 90 degrees clockwise. The other ones don't go clockwise. This one, that one goes 180. Down here, it goes counterclockwise. Up there, it goes counterclockwise. So again, those can't be it. Now, on number 6, this one, yeah, let me see if I can do something real quick, because that's really hard to write on a screen without knowing what I'm doing. All right, we're back. So on number 6, we have our vertices. They tell us that each one of these vertices is shifted or translated 4 units right, 6 units down. So essentially what we're doing is taking our original values, and then we're taking those and adding 4 to go right 4 units. Oops, didn't mean to do a parenthesis there. I meant to do a comma. And then we're going 6 units down. So we're going to subtract 6 from our Y value and find our points. Well, take the first value. We had -7 plus 4 and +6 minus 6. And that's going to give us our new coordinates at -3, 0. Now, out of all those options, there is only one of those that has A correctly shifted to -3, 0, and that's D. That must be our answer. Again, we could have gone through and found C and B as well, but we don't have to do those two if we don't need to. So we're going to go ahead and move on since we already found our answer. All right, on number 7, they give us a congruency statement. Triangle TRI is congruent to triangle ANG. The order in which they appear, the corresponding order, is very important because that tells us which ones are congruent. So like T has to correspond with A, so those two have to be congruent. So we know E right off the bat has to be congruent. Same type of thing for the segments. TR, the first and second one, are in the same positions as A and N. The first and second one's on the other one. So they have to be congruent. Now, there are 6 pieces in total that must be congruent here. They're all listed. Which 6 do I have? So I already have A and E. What other ones must also be congruent? Okay. All right. Well, Rn. Hold on. Rn and ing. Yep. So that was F and G. All right. So A, B, C, E, F, G. The only two that don't work are D and H. All right. Number 8. The vertices of triangle JKL have coordinates of, and they gave us a bunch of coordinates. We actually don't even need the coordinates on here. It says under which transformation is the image not congruent to the original. Well, on here, it gives options of translation, rotation, reflection, and dilation. 3 out of those 4 are congruency transformations. One of them is not. Which one's not the congruency transformation? D, the dilation. So that one doesn't work. The rest of those are called congruency transformations or rigid motion, meaning the first image and the final image have to be the same. So D is the only one that's not. D is what we call a similarity transformation. All right, 9 and 10. Number 9, for 2 isosceles right triangles, what is not enough information to prove congruence? So we do know that in each one of these, we're dealing with a right isosceles triangle, which means that we have a right angle and we have 2 legs that are congruent. The other thing that we know is in any triangle, you can prove that they're congruent if you have parts of side, 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 angle, side, side, angle, angle, or again, you can write that one the other way, angle, angle, side. And then you have angle, side, angle, and then HL. All right. Things that don't work, SSA, also known as ASS, or AAA, don't work. So looking at what they gave us, we already know that in every single one of these, we're dealing with a right triangle, and we have the legs are congruent. For part A, the length of all the sides. Well, that's SSS. We knew all the sides. We definitely know they're congruent. B is a little bit tricky. The length of the hypotenuse for each triangle. All right. Well, if I had the same hypotenuse in both triangles, could I have different length legs? Not if both legs are congruent. So B is kind of tricky. It's a little outside the box, but it works. So these 2 are already out. Option C, the lengths of a pair of corresponding legs. All right. Well, if I know one leg, I know the other leg, since they're isosceles, and I know the angle between them. So this is SAS. So that one's definitely something that works. So that's out. The only one that doesn't work, D, it's doing nothing but the angles. And AAA is not a congruency thing. That's a similarity thing. So D is the one that does not have enough information. On number 10, all they give you is the length of 3 sides. They don't tell you anything about angles. So when you're looking at these, the only one that actually works is B, because all the other ones are talking about angles. B is the only one that's talking about 3 sides, which is what these straws are representing. All right. On 11 and 12, we're doing a parallel line. So the first one, well, anytime we deal with parallel lines cut by a transversal, all the angles are one of 2 things. They either have to be the same or congruent, or if they're not congruent, then they are what? If they're not congruent, then they are supplementary. They have to add up to 180. So on here, look at your angles. Are angles 1 and 2 congruent? They look congruent. They don't look congruent. They're not in positions that need to be congruent. So they must be what? Supplementary. So we're going to take the 2 angles and add them up so they are equal to 180. That's what it means to be supplementary, right? So on here, we're taking our 2 angles that they gave us, angles 1 and 2, adding together, saying equal to 180. Now we get to solve. Combine all your like terms. 2x and 7x is 9x. 36 and -9 is positive 27. So we simplify. Now we have to get x by itself by solving. So eliminate the 27. Bring 27 over. Subtract it. You get 153. And then we have 9 left. And you get rid of that by dividing it off. And you have 17. So is our answer B? We got 17. I see 17. Should be good, right? No. Careful. The question is not what is X. The question is what is the measure of angle 1. So what do we still have to do? Well, not divide by 2, multiply. We need to plug it in, right? We have on here, measure of angle 1 is going to equal 2x plus 27. So 2 times 17 plus, sorry, not 27, 36. My eyes drifted there. So 2 times 17 is 34 plus 36 is 70. So our correct answer is D. Again, always make sure you're answering the question that is given, because if you have to find X, that's going to be an answer, but not every question is asking you to find X. Sometimes they ask you to find something else. On number 12, same idea. All of our angles either have to be congruent or supplementary. This is the one that had the error that I asked you guys to correct last week. So the second value on here that says TVQ, I said change that so it's TWS. So we have two angles, TVQ, 5x minus 22, and then TWS is going to be 3x plus 10. Are these two angles congruent or supplementary? They're in the same position, which means they're corresponding, which means they are congruent. So we're saying them equal. And after we set them equal, we can solve. So subtract 3x from both sides, gives us 2x. Bring the 22 across by adding an x is 16. Is that our answer? Or do we need to plug it back in? That's a good question. For which value of x? So this time we have our answer. It is 16. All right. What time do we leave on Mondays? I forget. 54. All right. These next two, I'm actually going to go ahead and just put the answers up here. I don't really like the way that they set up these two proofs. They left a lot of stuff out, a lot of steps. So yes, proofs is something that you need to do. Will you need to fill out an entire proof like this from scratch? No. If they have multiple spots for you to fill in, it'd be a drag and drop where you have to drag and drop choices in, or they might give you a multiple choice where you have to fill in one response. So I don't really like this question, the way they gave it to you. These are the correct answers that I put up on the board right now. So make sure you check those. And then we'll stop here at 14 today. And then we'll finish this section tomorrow and try to get all the way through 48 tomorrow to catch up. But again, you guys have 23 through 48 due tomorrow now. All right.